Today I'm talking about obsolescence management in the age of the circular economy. The background from this is that in many high value long term projects, more technology is being used than ever in order to make them faster, better, more economical, and more reliable. Many off the shelf component solutions have a reputation for being short or poor life cycle support and obsolescence. Consumers are increasingly concerned about the waste of short-lived products and are starting to request that products are more durable, reusable, and recyclable. This has led to the circular economy promoted by the Dame Ellen MacArthur Foundation. But only 25% of the UK population understand the concept of the circular economy. Essentially, it is about reduce. This is often talking about emissions, but it can also talk about waste, and it also can talk about pollution. Reuse, taking a product that has been previously reused and putting it into another application where it may have an extended life. And finally, recycle. This is taking the product apart at the end of its life and then using those parts either to repair other products or actually fully recycling them and making them new in that, like that. It is about the whole life cycle of the product and reducing the environmental impact. And I note the whole life cycle in common with obsolescence management. But the process is not linear. There are three types of economy that you can talk about in this scenario. You can talk about linear, recycle, or circular economy. In a linear economy, you buy your mobile phone, you use it, when it breaks, you get rid of it. In a recycle economy, you might have a product that might have several updates during its life cycle that extends the product life, which may include things like replacing batteries and the like. But in the circular economy, change is pretty much constant in the sense that the product is continually updated and serviced whenever it is needed to keep the product out in service as long as possible and extend the life of the product. So when it is finally disposed of, it is realized that that product is totally worn out. But what about planned and unintended consequences? Right, there have been a number of instances where planned or unintended obsolescence has had an impact on the perception of product usage. In one case, Apple with the iPhone, they decided to slow the software down on older models because the capacity of the battery was reduced during its life. This was noted, and now Apple are replacing batteries free of charge. But this has also led to the making illegal planned obsolescence in France. Worn out memory. Tesla have recently had to recall 158,000 cars because the memory devices on the controllers have been worn out because of the software usage. Again, initially Tesla refused to upgrade these cars, but now they are doing that because it's been a full recall. Printer cartridges. This has always been a controversial theme because many printer cartridges have chips on them to restrict the use of them, sometimes to limit the life of them, or also to make sure that they don't run out of ink. The printers themselves have become less durable over time because of the price of the printer cartridges and the profit margins from that. Lithium batteries being used a lot in modern new electric vehicles, and they're expected to be tens of millions of these traveling around Europe over the next 10 years or so, yet there's no capability for recycling those lithium batteries, which is something that will need to happen and is a potential innovation in itself. In the 1970s, British Leyland launched the O series car engine, and this engine had a reputation because one model of the engine had softened valve seats to cut costs. After the lead in the petrol was reduced, these engines started to fail on a regular basis. just outside the warranty and did not go down well with their customers. And there is well known that in the past there was a cartel with relating to incandescent bulbs with a 1,000-hour life, but these days that's no longer applicable because light bulbs are all LEDs. However, certain applications require incandescent lights, such as infrared cameras, because of the fact that the LEDs do not produce the infrared light. So how do we use obsolescence management in the circular economy? Well, there's quite a number of things that we can discuss, but that is really going into a lot of detail. The simple solution, let's find a common synergy. In the circular economy, you design product with disposal in mind with as little waste as possible. You ensure that product lasts as long as possible considering the use of the product. You're avoiding the use of hazardous and toxic materials that can be difficult to remove. You repair products in order to reduce the need for replacement. You consider reuse of the product in new applications for the same use, and you only recycle when no longer usable. And planned obsolescence is not accepted. In obsolescence management, you monitor and service replenish products to maximize life and reliability of the products. You repair of products to avoid the need to design out obsolete and unattainable parts. You reuse and refurbishment of products to extend the life, capability, and reduce cost. Reclaim reusable parts to provide serviceable spares. You replace parts if no other option is available. And you design out hazardous and toxic materials if needed by legislation or customer requirements. The primary thing is that you avoid unnecessary redesign. Is it possible to consider a common synergy? Well, I believe there is. And obsolescence management could be in the following 6 R's. Replenish. You get your car serviced on a regular basis, and there's materials that are constantly being replaced on that. Oils, seals, maybe even the odd battery here, there, light bulbs. Sometimes cars still have incandescent light bulbs, etc., etc. Then you've got repair, which is the obvious one. When a product breaks down, is the product easy to repair? Can we get into it? Can we get components? Are the components available? Reuse of product, and here I've shown an Raspberry Pi, a product that was designed originally for education use, but that actually can be used for other applications, and it can be reused again and again and again. Reactivate. If parts are broken and not been produced for some time, can they be reactivated and reproduced? Is there documentation, skills, capability to manage to achieve this? The Impossible project reacted to the film used in Polaroid cameras, allowing them to be reused long after the original film became obsolete. Redesign of products. This should be seen as a relative last resort, but there are certain circumstances where the products may require a redesign because certain parts are no longer available or they are non-serviceable. And then finally, recycling. And here's a really good example of recycling. Somebody has got an old V8 engine that they are putting into another car. Aligning obsolescence modeling. The circular economy looks difficult to comprehend as the resulting output looks potentially uncertain. However, the difficulty is really with context and conflict that can be separated. Not every product has the same life cycle, the same obsolescence risks. The impact of the circular economy will mean these risks will need to be managed in a more comprehensive manner. There's a really good idea in how this can be measured. Based on my paper, Managing the Cost of Aftermarket Repairs When Obsolescence Had an Impact in 2019, I discussed about different levels of engineering change, including new manufacturer, alternate part, minor redesign, major redesign, and new product. And these products were listed in order of cost. In this case, most expensive on top, and bottom, the least expensive. And it has been seen that these cost increases are likely by order of magnitude with each particular level. This can lead to a table like you can see on the right here that actually highlights the different colours of the preference of what one you want needed on a particular product. But note that this does not include component costs, manufacturing costs, replacement costs, and procurement costs. This would then lead into a management matrix table, like that is in Appendix E of IEC 62402-2019. As you can see on the screen, we have the 6 different aspects, the 6 R's, and on the left-hand side, we have the 5 levels of engineering solutions from new manufacturer to design new product. And this can then be integrated into some form of obsolescence management plan. A simplistic view like shown on this screen here, where the amber parts are, the amber locks are parts that might be non-preferred, but certainly viable. The reds are where you want to keep out. The greens, the preferred options. And in this particular case, you can see that there are some areas during repair where there is not likely to be any impact because of the type of repair that would be carried out. But it's also worth noting that the technology insertion and redesign could go hand in hand. This could allow obsolescence management into sustainability leadership. Strategy without tactics is the slowest route to recovery. Tactics without strategy is the noise before defeat. Sun Tzu. Obsolescence management could be the strategic key that opens tactical sustainable innovation in the circular economy. And here are a few examples. Recycled per circuit boards. There's been investment by a major satellite TV broadcaster where you have printed circuit boards that at the end of their life, they can actually be boiled in water, which would then, the actual PCB material would actually then be biodegradable. Modular smartphones. This is a smartphone manufacturer, Fairphone, that actually sells their phones in a way that they can be upgraded and have parts replaced. So, synthetic fuel for performance cars. Porsche are currently working with ExxonMobil to develop synthetic fuel based on captured CO2. This fuel is designed to run on performance cars without modification. The resulting fuel produces significantly less pollution and emissions compared with standard petroleum. So there are other innovations that could be supported by the circular economy. Synthetic aviation fuel, domestic hydrogen, powered heating systems, biodegradable plastic alternatives, product repairability assessments, e.g. iFixit, additive 3D printing, reducing waste and unnecessary stock, smarter logistics programs, including local manufacture, and green bonds funding long-term investments. Energy. Will your energy source become obsolete or banned, e.g. fossil fuels? Do you have a plan to replace them? What needs to happen to provide the innovation to do this? Automation, making sure that the products that are being automated and are reliable and have long-term support and do not need to be replaced every few years. What happens if the product line changes due to enforced obsolescence caused by environmental legislation? Can it be managed? Factories. What happens to the factory that produces part of your product closes? Can you preempt any potential legislation that may cause manufacturing plants to become obsolete? Can you build spares in a low volume facility where high volume manufacturing can become too costly? What if your supplier can make more money building a different product? Standards. Are the correct current standards being applied? If obsolete standards must be used, are there impacts or deviations due to environmental obsolescence? Can you update to the latest standards if you are asking for a manufacturer to bid for new spares and repair? Logistics. Can the distance of shipping the parts be reduced? Are there facilities local that can produce one-offs for repairing customer units? What are the complications of local manufacture, IP issues, export controls? Do new products present logistical problems? For example, the size of the new Rolls-Royce Ultrafan means only one aircraft in the world can ferry spare engines, the AN225. How long can spare materials and the components be stored? People, can they deal with ambiguity of this circular economy age? Are there strategies to cope with changing job roles? Do we have the right people to deal with the repair of products? Does the approach for designing new product change and is support provided? What is the impact of AI on automated processes? Will more people be needed to deal with the false positives? Do we have to have the people that are able to derive solutions from documentation gaps in mature products and otherwise considered obsolete? Software. Do we understand the software that is critical supporting the product? Is the software being maintained? Is the software no longer supported? That can the IP rights be licensed so it can be maintained specifically to support an old program? Materials and chemicals can be banned. What is the impact of supporting an older product? Is material substitution available? Are there methods of ascertaining whether the replacement parts are good enough without requalifying the whole unit? Is there product data that can help changing materials, e.g. a digital twin? Controls. Do third-party control systems like PLC have an impact on supportability of the product? Is there an upgrade pass, or does it have to be a last time buy that needs to ensure that spares are available? Plans and checklists. Are they easy to understand? Are they achievable? If there are known unknowns in the future, i.e. obsolescence of a particular material or substance, does the plans highlight this and provide guidance for selecting alternatives? Performance measures. Are they effective in dealing with the complexities of supporting the circular economy? Can they adapt in changing legislation? Long-term investment. What is needed to support now? What are the long-term liabilities? What are the new business opportunities, e.g. recycling lithium batteries? What cash can be saved by not developing a replacement product but supporting an existing product for longer? Here's a case study, an electronic unit. It's used in a high reliability application, used in 3 different applications, A, B, and C. The replacement unit used in later applications, unable to support units for spares due to complex circuits. Replacement will not fit in applications A and B. Could design a new unit, but it costs too much due to certification, over $20 million. Well, you can perform a rollover for campaign to use replacement unit where possible in application C, use remove units for spares to keep applications A and B in service, monitor obsolescence and reliability in service, and proactively resolve obsolescence for parts that can be replaced. The result is a maximum use of existing product and removing the need for a £20 million spend on developing new product. So going back to the old obsolete linear recycle and circular economy slide, obsolescence management pretty much is not done in the linear economy because there's generally no need to, but it is quite common in the recycle economy for a lot of programs, particularly infrastructure related programs where obsolescence management may occur. And that then needs to develop to help support the circular and more complex circular economy. So can obsolescence management support sustainability? Is it the key? Yes, it most certainly is. In conclusion, obsolescence management is a stepping stone from the linear to the circular economy. Obsolescence management plans will need to deal with the changes in support context throughout the product lifecycle. Some of those changes may not have been thought of during product development. Reuse of product may itself highlight new opportunities that have different obsolescence risks. Circular economy moves obsolescence management from complicated to complex, and sometimes product updates may be developed to overcome obsolescence to reduce the environmental impact. For example, synthetic aviation fuel. And that concludes my presentation. I'll now open up to any questions.